Imagine you live on an unstable planet in the far reaches of the galaxy. Once safe for millions of years, your home is now plagued with scorching heat waves and violent storms. Your entire species is under imminent threat of extinction. What choice do you have but to flee and find a more habitable planet? Back on Earth, this horror story might seem distant in humanity's future, but for the hundreds of tiny marine species living on our coastline, it is Armageddon. For them, traversing miles of rocky shore to escape climate change is as treacherous as interplanetary travel for humans. These wonderful creatures are millions of years older than humans, and in my eyes are like ancestral fortune tellers, because whatever tragedies they endure will likely follow in the wider ecosystem over time. By understanding how they respond to climate change, we can do more to protect them and the planet's environmental future. However, visual surveys used to locate these creatures are limited by the number of experts and often miss hard-to-see species. But what if there was a better way? What if everyone in this room could identify hundreds of species without even seeing them? Well, through the incredible power of DNA, we can. Everything that lives on this planet has DNA, and every second we shed DNA into our environments, which is known as environmental DNA or eDNA. Like a high-tech barcode scanner, I can collect and sequence eDNA from seawater to seek out marine life. So for my thesis, I set out on an epic adventure across the UK coastlines, like Mr. Spock armed with his trusty tricorder. My mission? To determine whether eDNA can accurately track our marine fortune tellers. And not only did I detect our fortune-telling species, but I found so many others that I wasn't even looking for. I uncovered 270 different species in just one water sample, and over 1,700 species across the whole project. I found that eDNA was very sensitive to changes in marine communities. This included changes over large distances, like between Scotland and Cornwall, or between Mars and Neptune if you ask the sea snails. But also within small areas, like between rock pools and open water in the same location. So even in ever-changing environments like the intertidal zone, eDNA show great potential to track species across their perilous journey through their mini-solar system. We're still far from real-time environmental scanners like in Star Trek, but could eDNA be the final frontier for our environmental crisis? Our origins began in the ocean, and if we understand its future, we can discover our own. Thank you.